guess we'll get started. My name is Brandon Alexander. I am a lead developer for Blackpixel, working on various client projects, and if I can, some of our products that we might use Kaleidoscope versions if you're unfortunate enough to use SVM still, and NetNewsWire. But today I'm going to talk about event delivery in iOS. It actually came from a blog series or an article series that I wrote earlier this year on the same topic, because I don't think there are a lot of people who use Notification Center, Delegation, KVO, but there are a few other things that we can use to deliver data and have it flow differently through your app. So that's what we're going to cover today. So what we're going to do is we're going to cover just brief overview of touch detection. So how the touch system works and how the data flows through it. What kind of set us up to talk about the UIKit API and this thing called the responder chain. And any Mac developers will know what the responder chain is, but it's something that kind of sits behind the scenes in iOS. And then we're going to talk about how to use the responder chain. So to start off, I have a little bit of a warning. We're going to talk about Objective-C. But there will be some Swift. But it's mostly going, well, most of my presentation, the slides will be in Objective-C. And there's one demo on Objective-C, but there is stuff in Swift. So touch handling. iOS devices are, that's how we interact with our applications, is through touch. You can also shake your device or use remote control if you have your headphones. There's also CarPlay that uses some of the same APIs. I could actually spend an entire talk talking about the touch system, but we don't have that much time, so we're just going to do a quick demo and talk about how the touch system works. So what I have is a very basic application that's got a bunch of views. So we have a blue view controller that has a sub view that's orange, and if you notice it extends beyond the bounds. And then we have a red view controller. So what I have over here is I have some breakpoints. Hopefully you can't see that too well. But I have some symbolic breakpoints set for hit test with event. So what we're going to do is we're going to tap just in the white space, and it spits out a lot of information. So what take a look at this. We have just a simple log message to have a separator. This is printing an object at register RDI. What that is, that's the first parameter of the method. Since it's Objective-C, that's going to be whatever object is getting sent this message. I actually found the reference to all these registers and where the parameters are set in a tech note called Mac Debugging Magic. If you search for Mac Debugging Magic or iOS Debugging Magic, we give you all sorts of information and private APIs and assembly the registers for various arguments and things to use while you're debugging your application. Since we're on a simulator, we're on a 64-bit Mac, and we have to use like RDI, RCX, all sorts of other registers, and we'll see those throughout the rest of the talk. So what we've done is we've actually started by tapping into that white space, and our first object that gets a message is a UI window, and it has no super view. Let me make sure that's the right. Yeah, we're printing out the super view. The next view down is just a simple UI view that's the full screen, and it is a direct subview of the window. And we keep on going. We have a layout guide. So what it's doing is it's searching the subtree, the entire view controller hierarchy, for objects that say, yes, the touch hit this particular view. And we go all the way down, and this view right here is the final view that did it. And in this case, it's in the view controller. And then we start over with the status bar window. You can actually see how iOS builds your entire application by looking at hit test information. So then we'll clear that out, and then we'll tap here in the orange space. And same thing, we've got the window, and it keeps on going, and then we finally have this touches.foo view. So what this is doing is this is saying, this is the orange view. If you look at the way it's built, we create this foo view, and its background color is orange. So it hits the foo view, and its parent is the view controller's view. And then it starts looking in the status bar window, and then goes through the entire process again. I haven't quite figured out why it goes through it twice, but this is an API that we really don't have to use or implement. There are some tricky situations where you do, but overall, this is something just to kind of help debug your application, because you might have a case where you have a view going outside the bounds and you have clips, subviews turned off. So if you tap here in this orange, you'll notice that it doesn't hit foo view at all, because as it's looking, as it's traversing the view, it goes to the window, the white space, and then it never hits this blue view controller. It never hits that blue view. So it doesn't go into the orange view, since the orange view is a subview of the blue view. So hopefully that'll make sense. So what we're going to do now is we're going to, so that was starting at the window and moving down. I like to think of it as the window at the top level and moving down the tree. Now what we're going to do is we're going to look at it from a different point of view by looking at touches begin on a class called UIResponder. So this is, if you implement touches begin on any of your views or your view controllers, this is the API that you're doing, but we're going to watch and see how the data flows through the application. So we'll start off in just the white space. So we have our view gets the touch, and then the view controller gets the touch, then window, application, and app delegate. So what that's saying is the white space gets the touch, so it touches begin, starts there, it flows into the view controller, and then up into the app delegate. So we'll clear that out, and then touch on the orange view. So the foo view gets it, and then it flows up through its parent view into the blue view controller and up to the app delegate. And then the same thing here. The orange view never gets the touch because it's a subview of the blue view controller, and the blue view controller never responds to hit test. So that's just a basic overview of the touch system. I'm not even getting into gesture recognizers, because gesture recognizers fit within the touch system and make things a little more complicated. I'll have a shortened URL for the blog series if you want to read more in depth about it. I'm still learning how gesture recognizers work within this, but you'll get a basic idea on how the touches flow through and how gesture recognizers can sort of short circuit and supersede some of these API that we've looked at. So let me get my notes So let's talk about the UIKit API around this. And we looked at the UIResponder touches began. Now we're going to look at overall some of the API that also supports data flow through your application. So we're going to talk about UIControl. UIControl uses the target action pattern. And that target action pattern allows you to define these control events that then send actions to a given target. And something that's not known a lot is when you tap on, say, a button, it doesn't send a message directly to a target. It actually goes through UI application send action to an object from a sender for a given event. So everything from UIControl flows through this method. So if you're having an issue figuring out, why is my button not, like, why is my target not getting a message from a button, set a breakpoint on this particular symbol, and it'll help you understand and figure out where things might be going wrong. So here's the header. I've removed some of the details about UIControl, but the pieces that are most important are add target. So you're adding a target for a given control event with an action. Removing a target, you can actually get all of the targets on a given control, and then all the different control events that are handled. And then the rest of I won't go through the rest of them because I'm pretty sure you can all read these. And you've probably worked with these before. But this is basically how UIControl works, and it uses some of the touch system methods and all of that to send those messages. And if you set a breakpoint, look at the stack trace, you can see where those work. Now the actions that you can perform from the UIControl, so the actions that a target gets sent, you can have 3 different signatures. You can have just the action name. You get no information, it just gets a method name. So you get sent just a simple action name message. You can then have the sender give the sender information. So like a button. You tap on a button, the button then sends a reference to itself as the sender. And then the one that I use more often than I used to is the action name for event. So you get the sender and a UI event with all the information about it. So that event, you can actually, if you want to do something custom, you can actually put information into a subclass of the event, piggyback some data on it, and send it up to your target. So now let's talk about the responder chain. Because the responder chain is this hidden thing that Methodum UI application actually uses. We'll talk more about how it does that, because there's a certain case where it does flow through the responder chain, and other cases where it doesn't. So on an iOS app, this is how the responder chain is structured. So you have a UI label, a text field, a button in this particular application. And then the next responder in this chain is the view they belong to. And then it goes up to, then that view, it looks for a view controller. There is no view controller in this case, so it goes to its super view. And this super view has a view controller. So its next responder is the view controller, and then it flows up to the window and all the way to the application delegate. Now this should look familiar from the touches demo doing touches began. It actually flows through the same thing, so it's actually using the responder chain for your touches began. So as I mentioned, the UIResponder is the backbone of the responder chain. It's the thing that defines all of the methods for passing messages to other responders in the chain. And there are also some system API, so you can handle some things like responding to shake events, responding to remote control events for your headphone controls. Those are just a small example. And then there's this concept of a first responder. By default, there is no first responder in an application. You have to actually tell the system, I want to become a first responder. And as soon as you do that, and you tell the system, I can become a first responder, we'll look at that API in a second. But as soon as you tell the system, I want to be the first responder, you are the first object to get that message, or to get an opportunity to respond to a message. And then if you don't respond to it, it flows from the responder chain from the first responder on. So if we look at this, and we set our view controller's view as the first responder, and you perform an action. None of the objects that are above the view controller's view will get a chance to respond. So here's the header, the Objective-C header for UIResponder. So we have a next responder object, since it's a chain, can become first responder, can resign first responder. There may be some instances where you don't want an object to stop being the first responder. And then is first responder. If you notice, all of those are read-only, so you have to use the system APIs. You can't override those properties. And then we have a bunch of events. That's touch handling, remote control events, shake detection. And then we have can perform action. So what this is doing is if you respond to this message to check to see if you can respond to a certain action, this is where you get an opportunity to say, yes, I respond to that action, or no, send it to my next responder. And then in iOS 7, they added this target for action, where you can say, I may not respond to this given action, but here's an object that does. And that object will get the opportunity to respond to it. And then for all responders, you have an undo manager. So every action you can queue something up in the undo manager and then undo it if you need. So let's take a look at, I'll show you the demo and then we'll look at the code. Oh, why is it stopping to build now? Seriously? This literally worked half an hour ago. There we go. I'll figure this out before I post the code up on GitHub. And in the speaker notes Slack channel, I'll post that. So what we have this application where by default a given view, and we really don't know which one it is because of the way the application is built. Either this orange view or this orange view will respond to a message. So I'm going to hit Command G. Where's the top one? So when I hit Command G, it turns green. But now if I tap on this blue, the top view controller, this is now the first responder. So if I hit Command G again, it's going to turn that orange square, gray. So then I can tap on the bottom one and do the same thing. So let's look at the code and see how this. So first we have this foo view. And I forgot to mention that UI view and UI view controller extend UIResponder. So they're responders, and they can participate in the responder chain. So this foo view, it can become a first responder, and then it implements key commands. So these are keyboard shortcuts that you can do on iPads. It's really handy for an iPad Pro when you have the built-in keyboard. So in this case, we're responding to the command modifier with a G. And then we're saying the action is G key pressed, and that's where we say set the color as green. So in view to load of our blue view controller, actually let me go back to the storyboard and show you that we have two container views, and each one is an instance of blue view controller. So when our blue view controller is created, we have in view to load, we're building this foo view and then telling it to become the first responder. And then we have a gesture recognizer on the view controller's view. When it's tapped, it becomes the first responder. So now what we're going to do, we have an extension where we say we can become first responder because we have to tell the system, yes, we can participate in the responder chain. And then in become first responder, we're doing some extra things. We're setting the background color to blue, so we can say this view or this view controller is the first responder, and then reset the foo view's background color. And then when we resign first responder, set it back to gray and the foo view back to orange. And then call super. And then since we become first responder here in view tapped, and we want to respond to the same command G command, we implement that on the view controller. So what we're doing is we're able to tell the system, I want this particular view to be my first responder and respond to some key commands. In another instance, I want my view controller to respond to these key commands. So we're able to manipulate the first responder and understand how these things come together. So I've got we'll set a breakpoint on become first responder. So, and I know that's probably hard to read, but in view tapped, this looked different half an hour ago. So we'll move on back to our slides. So we looked at how to use and manipulate the responder chain so we can have different views or view controllers become the first responder and see how these things work together and use the same, in this case, same key command to do different actions. So we saw that we implemented some methods on UIResponder, and now we're introducing a new thing called a null targeted action. So when you create a target action, when you assign an action with a target on UIControl, you can actually assign nil as a target. What that's doing is that's going to say, on this button, touch up inside, we're going to send this message down the responder chain. So instead of having a specific target, we can actually have this button perform an action to send it up the responder chain. And then we can actually send custom targeted actions, not even specifically on a given UI control. So let's take a look at how to do that. Where's that code? So here's an Objective-C. We're going to look at a Swift version of this project, but we're going to So this is a fairly basic application. We have all the different Star Wars movies. The first 3 minutes exist depending on where you are and enjoying these movies. What we're going to do is when we tap on Set Title, we're going to set the title of our navigation bar. So what we're doing here is, this is probably a case where you've, something you've done in many of your applications. We have a table cell, the button, we need that button to do something. But we don't want our cell to do the work. So how do we solve that problem? Before I understood how the responder chain worked, I would have a delegate on the cell, and then assign the view controller as the delegate, and sort of tightly couple those things. But what if you need that delegate message to go up a couple levels to a couple of parent view controllers? Well, you could chain delegates and have messages flow that way, or you could use the responder chain and have it do that. I actually had to do that on a project about 1.5 years ago. And when I did that, the rest of my team was like, "What are you doing?" And I showed them how it works, and they're like, "Oh, that's cool." So let's take a look at how this works. So I have a breakpoint set. We'll look at that in a second. But we have our basic table view boilerplate. And then we have our cell. We're configuring it with the title. And then we have this button action assigned to our cell, because we may want our cell to do something special just within the cell. And then what we're doing is we're creating a custom event, giving the event a title, in this case the title of it's a piece of information from the model on the cell, and then sending a message using that same send action to from for event. Except in this case, instead of having a specific object in the to field, the to argument, we're sending none. And then in the view controller, we implement the update title for event, and then set our title, which then sets the navigation bar title. So what happens, so we're looking at this can perform action with sender. What this is doing, this is checking to see, okay, I'm at a given object in my chain. Can this object respond to this action? No, move on to the next one. So let's take a look at how this flows up. So we have this table view wrapper view, some private API that Apple uses to build the table view, and then it moves up to the table view, and then we hit our table view controller. It can respond to it. So it stops there. It doesn't flow on. So if I take and comment the action out, you can see it goes way farther. So we have our table view wrapper view, it flows up, hits our table view controller, a view controller wrapper view. And again, this is a good way to see how iOS builds your application and gives you a better, more of an appreciation for how this works and helps you understand where things might go wrong. So we have our navigation controller window, and then flowing up to the application and the app delegate. And the app delegate is always the last, it's always the last object given a chance to respond to a given message. So now, let's set So if you remember what I said earlier, by default there is no first responder. So in this case we're going to tell the system I want to become the first responder. And what should happen, what happened half an hour ago, if you notice, we still didn't implement the method, we still have it commented out. But the top one is that table view controller. That's the first responder. So we didn't have the table view or its super view. Those didn't get a chance to respond to the message. So what this is saying, this is the actual first responder. So something that's kind of tricky, and I learned this a little bit ago. I set a breakpoint, a symbolic breakpoint on become first responder. It's called on our navigation controller first. I know that might be hard to see, but that's a navigation controller. Then it's called on our window. And now it's finally called here in our view-to-load method. So let's comment this out. So again, navigation controller, window, navigation controller gets it again, and then that's it. And something that I found that was a little strange is there, at some point, this table view controller becomes the first responder, and then it stops becoming the first responder. And I haven't quite figured out where that happens, but at some point it becomes the first responder and then stops, and that's where the default of no first responder happens. And now let's look at the Swift version. So I like the Swift version a lot better. And it's the same exact application. I'm not going to go through and show you what it is, but I like it because we have a specific, like we can have this self-documenting message. So we can create this responder chain action sender type. And if you remember, that method that we called on UI application was a long send action to, from, for. We don't necessarily want to type that all the time, so I created a message or a method called send nil targeted action. We call it a responder chain action sender type. And then that is exactly what our table view cell is. So it has this method. And if you look here, because we have to define a selector, so in this case I have a selector defined as title updated, and it's defined as an extension on selector. And then we have to give it a specific method to use, and then we create a protocol called title table view controller or view cell action handler. So what this is doing is this is saying anything that conforms to this protocol, has to implement this method. So what this is doing is saying in our view controller, we conform, so we have to implement that method. So we know what our table cell will send up the responder chain. So it's more of a strictly typed system, whereas in Objective-C, you can just throw messages everywhere. Just send a message and you have no idea what's going to happen. But in this case, it's strictly typed, and we can get a better idea of how data is going to flow through our application and not have to rely on comments. And that is the end. So thank you very much for sitting through this. And there's my contact information. Follow me on Twitter if you want to get a picture of my kids. And that is the short URL for part 1 of my article series. And it's basically the same thing, but part 1 covers the touch system more in depth. And then I'll have all the code posted up later today, along with these slides. Yes, question?
That no-target selector trick is really cool. If you have multiple handlers in the responder chain and the same action.
You can, but the first one that gets it is the one that handles it. Yeah, it's the one that gets the event. If you remember in the touch, and when we were manipulating the responder chain and who becomes first responder, we were using a specific method on UIResponder, but that applies to nil targeted actions. So we had our center view that turned green when we hit Command G, and then when we tapped on the view control, or the view, its parent view, it turned blue and became the first responder, and it was given the opportunity to respond to that message. Does that answer your question? Any other questions? Yes?
Creating a custom event that's purely for minutes, you're not passing a whole bunch of touch-up insights.
Say that one more time, I'm sorry.
At one point you created your revolving event, and you're passing it up, and I'm just assuming that's just so you can further isolate which event it is, and there's confusion of always passing touch-up insights.
So the question is, creating a custom event is a way to...
Or I guess if we're going to put it from a question, what was the point of creating a custom event?
So what was the point of creating a custom event? What that was is basically being able to give model information from that cell, and passing it up the chain, so anything that handles it gets information. Instead of just a message saying do something, we need to say do something with this data. So it's not really a matter of checking the type and being able to handle it that way. You could, but it was really just a way of packaging a bunch of data with this message and sending it up the chain. Any other questions? Yes?
So first responder and resign, does it actually just manage that one particular instance, or does it actually queue it up? Do you have any insight on whether or not it queues it up in the iOS system? Or, like, for instance, if you don't do resign, what happens? Does it actually queue it up and continue to hold on to it if it goes into the background? Does it queue up other ones as you go into other view controllers and say first responder? Do you understand that question?
I think I do. The question is, does resign first responder, if you don't resign it, does it queue up those messages?
Does it queue up that first responder request on one view controller, and if you move to another one because maybe you have some network communication that moves to another view controller, if you don't manage that, what happens in the background? Any insight on that?
That's a really good question. I don't know. My instinct is that if you don't resign your first responder status, say if you're a view controller and you push another view controller on the navigation controller stack, it's still was the first responder. I'd have to do some debugging and figure that out. But using the techniques that I showed you can just implement resign first responder and see what happens.
Sure. So I guess I'm going at it like as if you want to keep it as a first responder. You go into the background, they put it, user puts it in the background, there's some network stuff goes on. When it comes back out, there's no reference to it because you've actually you wanted to keep it, but then you want to come back out. And I've always wondered if that actually goes away with another first responder request. Like it's,
yeah, you can only have one first responder. And the use case you're thinking of, you might want to rethink your approach.
Yeah.
So this particular approach is for not a specific set of problems, but it's one way of solving a problem that you can do with Notification Center. But it's something that is specific to this being able to have data flow through your application.
Sure.
Something that I did know that your question reminded me. When your application is launched and you say a muted load, say become a first responder, that object does not become the first responder immediately. Because if you have a view controller and muted load, that view, your view in muted load does not have a window. And you can't participate in the responder chain if you're not a part of, if you can't exist within the responder chain, if that makes sense. So what that does is actually queues up and it says, I forget the exact API, but it says become responder chain if necessary, or become first responder if necessary. And that takes me to one other thing. If you're in Objective-C, I haven't figured out how to do this in Swift yet, but if you're in Objective-C, you want to see what the first responder is. Ask the window for, so you do like self.view.window dash greater than underscore first responder. That'll give you your first responder. Just a little bit of undocumented API to help you debugging. Any other questions? I really hope this was helpful, and I hope you can start using this technique in your apps as soon as possible. So thank you again.